Next, I will explain about the example for absorption kinetics, isotope, and also thermodynamic. In this term, I choose methylene blue absorption on polyaniline and polypyrrole macro nanoparticle. So the first one is the absorption kinetic, where figure A and B is pseudo first order model of polyaniline and also polypyrrole, and CD is the pseudo second order model of polyaniline and also polypyrrole, and the E and F is the intraparticle diffusion kinetic plot of methylene blue on polyaniline and also polypyrrole. So this is the equation that used in this part, where Qt and Qe represent the amount of methylene blue adsorbed at equilibrium, and Q1 is the rate constant of the pseudo first order model, K2 is the pseudo second order model rate constant. The kinetic parameters such as Q1, K2, correlation coefficients, and calculated Qe value are resolved by a linear equation. Is shown in the table 1. Alright, so the QE value of both of model are in agreement with the experimental data, where QE for polyaniline is 18.7 milligram and QE for polypyrrole is 16.1 milligram per gram. So figure 5E and also 5F shows the multilinear plot of the intraparticle diffusion process of the methylene blue adsorption process on polyaniline and polypyrrole. As shown in here, which is figure 5E and F, the slope Ki of the intraparticle diffusion stage is smaller than that of the film diffusion stage. This result indicate that the intraparticle diffusion stage is gradual process. So this is the Ki value here. So the next one is in terms of adsorption isotherm, which is figure 6A and B is the Langmuir and CD is Froehlich's isotherm model for the adsorption of methylene blue onto polyaniline and polypyrrole. So the observed data of the methylene absorption onto polyaniline and polypyrrole are fit to the Froehlich-Langmuir model. The absorption occur on monolayer, which is for the Langmuir, where all absorption site because the absorbent surface is homogeneous. In contrast, the Froehlich absorption assumes that the multi-layer absorption process is localized to a heterogeneous surface. The linear equation of the two models are presented above. The monolayer absorption value determined from the Langmuir isotherm is 19.67 milligram per gram for polyaniline and 16.69 for polypyrrole, which is in agreement with the experimental data, 19 milligram per gram. So this result indicate that the absorption of methylene blue onto polyaniline and polypyrrole follow the isotherm model. So the last one is in terms of thermodynamic analysis. Figure A is temperature studies on the methylene blue absorption onto polyaniline and polypyrrole, and the B is the Van Hoff for the thermodynamic parameter. The experiment were measured using 50 milligram of polyaniline or polypyrrole in 20 ml of the initial concentration of methylene blue at different temperature, which is between 20 until 50 degrees Celsius, with a fixed contact of time, which is 40 minutes. The removal efficiency of methylene blue increased when temperature is increased to 50 degrees Celsius. This result can be shown that the evidence there will be many absorption sites for methylene blue at high temperature. The negative heat free energy here indicates the absorption process is spontaneous and feasible. The positive enthalpy value here show that there is endothermic process which is consistent with the effect of temperature, and the positive entropy here depict that some structural changes in the polymer and methylene blue, increasing in the randomness of the cell phase during the absorption process. So I think that's all from my part. Thank you.